Hey everybody, today we'll do another math problem. And today we will do, which is called integration by parts. And this is, it's called a definite integral because we're looking for a finite answer. We're looking for a number, basically. So basically, what integration by parts says right here is that if u is equal to f of x and if v is equal to g of x, then f prime of x and g prime of x are continuous, right? That's the definition of it. If u is equal to f of x and v is equal to g of x, then f prime of x and g prime of x are continuous, right? That's all it is. Now, let me just do this problem, right? Because the most important here is not the definition, it's not the big definition of this. The most important is how we solve problem using this tool, right? So the integral of u dv equal to uv minus the integral of v du, right? That is the integration by part formula. Now, how do I actually solve this problem? That's the first question, right? How do I use this tool to solve this problem? I got the integral of x times e to the 2x dx, right? So I have multiplication going on here. So that means anytime that you see this multiplication going on, you better start with this tool, right? Okay, now let's do this, right? So let's do this. Let's do this quick. Okay, so I got what I'm going to do. I want to let u, which is this u, be the simplest function on the problem. Well, the simplest function in this problem is x, because the derivative of x, right? The derivative of x, right? So the derivative of x is simply, right? It's, if somebody asks you a question, said find the derivative, first derivative of x is simply dx, right? That's it. Now, how do I get dx here? Let me just do this little quick. Okay, the formula for the derivative is following: d over dx of a number, right, is equal to what? Is equal to of a function, because we take the derivative of a function usually. Okay, so this is basically what? This is I don't know if this marking is working. So a n x to the n minus 1, right? What I do is I bring the exponent in front and minus 1 to the exponent, right? Now, so let's do the derivative of x little quick, right? So here, x is already there, so basically what I can do here is the following, right? So the derivative of x, right? Let's say some books write it like this, right? Derivative of x is equal to what? Is equal to the derivative of this, right? This x is equal to what is the coefficient? The coefficient of x here is 1, right? So 1 times what? A is 1 times, right? Times the power, which is, well, that is with the 1 power, right? So that becomes in front times x, right? Minus 1 to the power, what is it? Minus 1 to the power, if n is equal to 1, and I minus 1 is equal to 0, right? So then this is technically any number to a 0 power is 1. So technically I get what? I get 1 times 1 times 1 and dx, which is equal to dx. That's how you get dx. And the books, they're not going to explain that. The books, a lot of time you say that the derivative of x, derivative of x is equal to dx, right? That's it. A lot of books, they don't take the time to explain that you got a 1 in there in front of the dx, right? But anyway, that's it, right? So now, what is the easiest function? The easiest function to take the derivative or the integral of is x, right? So I let u is equal to x, right? Take the derivative on both sides, I get du is equal to dx, right? So now I got that taken care of, right? So I got now that u is equal to du is equal to dx, right? Now here I gotta so I gotta now find what is d, right? So I gotta now I will replace v right here, dx, du right there. So dx is equal to du right there. Now we gotta find b. That's it, right? And when I find this b is going to be that one, right? So now I wanna find v, right, by doing the inverse, right? Now I said dv I'm going to integrate now to find b, right? Because see, I got a dv here, so dv is equal to what? Is equal to this function, which is e to the x dx, right? When I integrate this, I get v, right? So I integrate both sides and I get v here. The integral of dv is just v. And the integral of e to the 2x, these two come out to the bottom, and I get 1/2 e, 1/2 e to the 2x, right? Plus c. We're not going to worry about that right now, right? Because we're not doing indefinite, we do indefinite integrals, right? So technically this is e to the 2x over 2, right? So that is the integral of that. That is u now. I'm sorry, that is v, right? So now that I have the v and I have the u, I can actually apply this formula, right? So here, what I'm going to do is substitute the values of this and this. Now, notice that over here, all I have to do is u is equal to x, right? Well, replace it, right? Replace it by x here. And v is equal to e to the 2x over 2, replace it right there. And I'm going to get what? I'm going to get x multiplying, right? Multiplying e, because that's what it's telling me, the formula, e to the 2x over 2, over this 2 here, this 2, minus the integral of v, which is this guy right here, So it's e to the 2x over 2, right? Now, and this is evaluating, we can put from 0 to 1, right? Okay, so let's do this. So this I don't have to do anything with it, right? I did whatever I have to do in this piece, all right? So that becomes x multiplying that e to the 2x over 2. The integral here, the integral is what? The integral is minus, when I integrate that, becomes what? Becomes, this becomes to the bottom, right? This 2 becomes to the bottom and becomes what? Becomes e to the 2x over 2 times 2, right? Which becomes what? Becomes x times e to the 2x over 2 minus e to the 2x over 4, evaluated from 0 to 1, right? But notice that if you take in the class and say, find that indefinite integral, this is the answer. Just add a plus here, right? So the answer would be just x e to the 2x over 2 minus e to the 2x over 4 plus a constant, plus c. Right? That will be the answer for indefinite integral. But are we looking for the definite integral? But again, if you're being asked to find the answer for indefinite integral, this is it. Right? So, let's erase that. Okay, now we evaluate this integral on those limits of integration, right? So, and let me, for those, I think I did it in a definite integral before, but let me just do a little quick here, a review on this. So basically what it does is the integral, this becomes one of the second fundamental theorem of calculus, is basically some integral evaluated from a to b of f of x dx, right, is equal to big F b minus big F of a. That's it. Right? I believe that's what it, I mean, you can review this and verify it, but something like that. You will end up with big F of b minus big F of a. Right? So, okay. Okay, let's do this. Okay, so now let's substitute the values for that, and that's when it becomes kind of tricky, the arithmetic of it. It's very, very simple. It's very easy to make mistakes here because we use substituting values and okay, so let's do the first one. First we apply in 1. See? Say, I call it this to help me out. I call it the bottom point and then the top point. Top minus bottom. That's what I call it, right? Top minus bottom. So I plotting 1, right, for x, right? For this x, plotting 1 times, and I want to be specific here because I'm multiplying. So I multiply the function here being multiplied, that right here. So multiplying e to the 2x to the 1 power, right? Over 2, right? Minus what? Minus the same function again, right? But what I usually do here, right? So well, now I am doing this piece right here, right? So minus e to the 2 x minus 1 over 4, right? Then minus the following, minus evaluated as 0, right? Minus the whole piece evaluated as 0, which is what? 0 times e, right? To the 2 to multiply by 0 over 2 minus e to the 0 power over 4, right? Notice that this is 0. See, I multiply it by 0, right? So let me just make it clear here. This is a 0. I'm going to write this. This is a 0, and this is the multiplication. Right? When I multiply it by 0, this becomes 0, right? So this whole thing right here is 0. This piece, right? When I distribute that sign into that piece right there, becomes a positive, right? If I change this sign and multiply that, this becomes positive, that becomes positive, right? This becomes a negative, but doesn't really matter because it's that 0, negative 0 is 0 anyway. So we don't even have to write that down, okay? So here I get what? Here I get e to the second power over 2 minus e to the second power over 4, right? Right? So then that is that piece right there minus or plus, because I changed the sign, plus this piece right here, right? So this becomes what? This becomes, when I change the sign, becomes e to the, actually no, wait a second. See, this is the tricky part here. See, that's what I'm saying. When you multiply this, any number to the 0 power is 1. So that the whole thing, this whole thing becomes 1/4. See that? Now, I'm just adding these two pieces, right? I want to find the least common denominator for this, and then add this is, and I will be done, right? So this is going to be what? This is going to be, what? It's going to be 2, I'm multiplying by 2 on both sides, right? Times e to the second power over 2 times 2, right? At the bottom, plus, no, minus 1/4, minus 1/4 e to the second power, right? So when I add this, when I do this math, this is equal to 2 e to the second power, right, over 4, right, plus, now minus 1/4 e to the second power, right? Then this plus 4 comes here, right? Plus 4 comes here. Plus 1/4, I'm sorry, right? Now, if I add these two guys right here, what is going to happen? This is going to be simply 1/4 e to the second power, e to the second power. This is a new, it's a no board though. So it's going to be, this is going to be simply 1/4 e to the second power plus 1/4. Alright? Sometimes the books like to write it like this. Right? So the book like to write it like this. 1/4 plus 1/4 e to the second power. And that is the answer for that. If you plug this number in the calculator, because you got an e in the calculator, you will get a number. E is approximately 2.71, and it's a big decimal. So that is the answer for that. That is the answer, and also this will be an answer. Okay, so that is the answer for that problem, and I hope you learned something out of this video. I hope this video helps anybody who was taking calculus. Thank you for watching, and don't forget to subscribe if you like this video. Thank you for watching.